All right, this is special parallelograms. So rectangles, squares, rhombuses, more specified parallelograms. All right, so what we're doing here is looking for, using the properties of special parallelograms to find missing sides, missing angles, the diagonals and such. So for the rectangle, we know that PQ is 24 and PS is 10, and we know this angle TPQ is 27 degrees. So find QR. Well, QR is going to be the same as PS because opposite sides are the same. So that means this is 10. Then SR, well, opposite sides are the same, so SR is going to be the same as PQ, so that's going to be 24. Excuse me. Now SQ is a little different. That's the diagonal. Well, since a rectangle is has a right angle, that means this is a right triangle. So we do Pythagorean theorem, and that's 10 squared plus 24 squared equals x squared. Well, that's 100 plus 576 equals x squared. So 676 equals x squared. Take the square root of each, and 26 is x. And so SQ is 26. Now, in a rectangle, the diagonals are congruent. So if SQ is 26, then PR is also 26. Now, QT is here, but in parallelograms, the diagonals bisect each other, so that means QT is half of the diagonal, so 26 divided by 2 is 13. Now for the angles, well, SPQ. SPQ, that's this whole thing here. Well, that's the right angle, so that's 90 degrees. Then we've got SPR. Well, that's this piece, and so that's 90 minus 27, or 63 degrees. Now, SRQ, well, that's the alternate interior angle, and alternate interior angles are congruent, so that's 63 degrees. Excuse me. Now QSR, that's this one, and STR, well, this is an isosceles triangle since are bisect each other and they're congruent, so that means this is also 27 degrees. So if that's 27, that's 27, and so this is 27. And then STR is right here. And so if that's 27, this is 27. And so 27 plus 27 is 54. And this triangle plus these two make 180. So 180 minus 54 is 126. And so that's 126 degrees. And that's all we're doing. It's just finding the missing pieces. Now, they could give us equations that we have to solve. So they could give us this is x plus 7, and that's y plus 3, and give us things to solve. But that's essentially what we're doing. We're just figuring out the missing pieces. Okay. Now, a rhombus, we're going to use the rhombus properties. Okay. So, we know that JK is 12, we know JN is 7, and we know that this angle is 38 degrees. So when it asks for JM, well, a rhombus, all sides are the same, so JM is also 12. Now, the diagonals bisect each other. It's asking for JL, so this entire thing, so if that's 7, this is 7. JL is the whole thing, so that's 7 plus 7, so that's 14. Now, MN is this piece. Well, we know this is 7, we know this is 12, so we do the Pythagorean theorem. 7 squared plus x squared equals 12 squared. Well, that's 49 plus x squared equals 144. We subtract and get x squared equals 95. And we take the square root and get to the nearest tenth, 9.7. And so, MN is 9.7. And then for MK, hold on. And so since MK, excuse me, is the entire distance, if this is 9.7, that's 9.7. Well, 9.7 plus 9.7 is 19. I don't know why I'm writing over it. I have an eraser. That's 19.4. And then when we look at the angles, okay, well, MJN is right here. Well, it's probably easier to start with angle 3. And one of the things we know about rhombuses is the diagonals bisect opposite angles. And so that means all the diagonals split into 2. So that means that JMN, if that's 38, that's going to be 38. Then alternate interior, JKN. So JKN or JKL or NKL. Nothing with K in the middle. All right. Or yeah, JKN right here. JKN will also be 38 degrees. Because that, and that will all be the same. Just like this one, and that one, and that one, and this one will all be the same. Now, we also know that in a rhombus, the diagonals are perpendicular. So that means, despite my bad drawing, that they make 90-degree angles. So that means JNK is 90 degrees. So that tells us that this is 90, that's 38. So then to find NJK, or this one, we do 180 minus 90, minus 38 and get 52. So NJK is 52 degrees. Well, that means MJN is also 52 degrees. And then NKL, well, that's 38 degrees. KLN, that's got the 2 arcs, so that's the same as that up there, so that's 52 degrees. And then MLN is going to be the same as that, so that's also 52 degrees. And that's all there is. Because basically alternate interior, alternate interior, alternate interior, alternate interior, and these are all 90. And then finally, we have the square, probably the easiest of all, because it has all the properties above. Well, AD is 11. So it's S for BC. Well, since all sides are the same, BC is also 11. Now it asks for AC. Well, since all sides are the same, that's 11 squared plus 11 squared equals x squared. Well, that's 121 plus 121 equals x squared. So 242 equals x squared. Take the square root. And to the nearest tenth, we get 15.6 equals x. So AC is 15.6. Now, BD is just the other diagonal, and since the diagonals are congruent, that is also 15.6. Now, EC is half of it, and since the diagonals bisect each other, we take half of that and get 7.8. And then for our angles, DAB is a 90-degree angle because, well, every angle in a square is 90 degrees. Angle AEB is 90 degrees because, like a rhombus, the diagonals are perpendicular, so they make 90 degrees. And angle CBD, so right here, is going to be 45 degrees because the diagonals bisect the opposite angles. Well, so that means it cuts it in half. So half of 90 is 45. And so BAC would also be half of 90, so also 45 degrees. And that's everything we're doing today. So it should be a fairly easy day.